Recording. Okay, so we're going to have a look at this you should already know how to do. So question 6, use properties of similar triangles. So how do you know if two triangles are similar to each other? Yes?
They have the same angle?
Same angles, plural. Okay, so a triangle can be bigger or smaller, but I know if this angle is the same as that angle and this angle is the same as that one, then I know all three angles are the same in each of the three triangles, therefore they're similar. So what does that mean? Well, that means that if I go from the smaller one to the bigger one, if I multiply by something, every single side gets multiplied by the same thing. Okay? So, for instance, we are told that this question, we've got 16 and x, and this one's 21 and 24, and we're basically being asked to find x. So I want to know what is the number that we multiply by. All right? So I set up well, I can either set it up as a ratio, or I can set it up as another algebraic equation, or however you want to do. All right, so what I might do is I know that the ratio, or the fraction 16x, okay, is equal to 24 divided by 21. Why is that? Thomas?
Both triangles, 24 and 16 are in the same place.
Yeah.
21 and x are in the same place.
Exactly, yeah. So we know that this ratio of size, so that's one way of expressing it.
How come it's division?
Because it's a proportion, it's a ratio. So ratios are a division, aren't they? Like a fraction is a division. Another way to write this would be x multiplied by something makes 21. And in the same way, I could say that 16 multiplied by something equals 24. There's a different way of writing it, right? So several different ways to express this. Another way to write it would be that 16 to 24 is the same thing as x to 21. I have to go in the same direction. So I've got lots of different options for how to do it. So which one would you like? The first one. Okay, so let's have a look. If we've got 16 divided by x has to be the same as 24 divided by 21. That's true because they're similar shapes. How can I go about solving that then? Well, they're fractions, being divisions, so we're going to try and simplify fractions, find equivalent fractions. So it's the same thing as doing this really, but what I need to do is put it in a way that I can, these are equivalent, but it's hard to go from 16 to 24, isn't it? All right? But it is possible. So what I'm going to start doing, I'm going to say 16 to x. Well, that's the same. What goes into 24 and to 21?
7. No. 8. No. 3. 3, yeah.
3. So if I divide the top and bottom by 3, I keep the same fraction, don't I? But it's an equivalent fraction. So what would it be? 8 over 7. You happy with that? Can you see now how I could get from 8 to 16? By doing what?
Times it by 2.
Times it by 2, top and bottom. So that would be 16 divided by x is equal to 16 divided by 14. So what do we, have we solved the problem?
Yes.
X equals 14. So there's my answer. All right. Just to show you how it would work, I'm just get rid of that. using this method, I can say that, well, same thing here. I can divide both sides by 16. Are you happy with that? I'm going to work out what k is. So k equals 24 divided by 16. Make sense? So forget that top line. I'm going from this point down. So I've divided both sides by 16, yeah? Using my algebra. So k is 24 divided by 16. Yeah? All right. So just to explain, I've started the same question but using a different method. So this is fine. We've got x equals 14. I'm going to do it this way and hopefully show it's the same thing. So if 16 times by something gives me 24. Michael, you got a question? No? So I can then stick this up here and say, right, so I've got x times 24 divided by 16 equals 21. So we can use our algebra skills. So any ideas? How do I do x times 24 then divide by 16? Has to be, I have to get back to just x equals. What can I do? Yeah.
Yeah. By dividing 24 by 16 and then dividing it by itself.
Oh, I don't get it. Read that to me. We've got x multiplied by 24, then... See, that word over confuses you.
Times by 16.
What is over actually?
Divide.
Divide. That's why we ought to say 24 divided by 16. Yes, you can do 24 divided by 16. Could you just, Daniel, could you just do it for me though, on your calculator? Can you do 24 divided by 16? What is it?
1.5.
1.5. Okay, so x multiplied by 1.5 equals 21.
Now would you do x times 1.5 and then divide by 1.5?
So now we
That's what I
could
said, but I just said it very
divide by the 1.5 gives me x equals 21 divided by 1.5, which equals, you got your calculator? 14 again, so we get the same answer. Now, hopefully, what I was hoping you would say, because this tests your understanding, at this point, I was trying to get you to say it's x, then it's times 24, and then divide by 16, and I get the answer 21. So what do we do first? We multiply by the 16 to get rid of the divide by the 16, and then we divide by 24. So it would be x equals 21 multiplied by 16 and then divided by 24. What do you get if you do that on your calculator? You'll know what the answer is, but let's just check. Can you actually do it? Is everyone going to do it? Some of you are not going to bother. Yeah? Because the reason why I say do it is because you'll look at that and go, yeah, of course it's going to be 14. It does equal 14. But if you don't actually do it, come test day, you won't.
So my calculator is broken.
Get a new one. You'll need to get that sorted done. Guys, we haven't got time today to wait for you all to have your own little discussions and things. Do you all get 21 times 16 then divided by 24 gives you 14 again? Okay. So that's how we deal with similar triangles. Now, the next question I'm not going to actually do. I'm just going to show you that. Yeah?
If we don't have any questions at the moment, can we still come tomorrow morning?
Tomorrow morning you've got after in the second bit. Well, we've got normal schedule and stuff in the afternoons and stuff. Yeah. Right. So this question, this triangle looks like this. All right. Now the problem here is that people think of it as a triangle and a trapezoid. and it's not. Okay? So what I would be saying is we change it into, here's the small triangle on the top. Yeah, it's the small triangle and...
It's the small triangle inside of the little triangle. It's
What?
the little triangle.
What?
It's the little one inside of the big
Right.
triangle.
How do we show, how can I prove that they are two similar triangles, just like with the other question? Pardon? What's the, what?
Because they both have the same angle.
They do. So this angle is shared in both triangles, yeah? So I can say that that one and that one must be the same.
And the little one's lines don't come off the big one's lines, so that would also hint that.
Okay, so because these two are parallel, that means this angle is the same as that one. And therefore the third angle has to be the same as well. So we know they are two similar triangles. Now obviously the way this one works is we've got 15 here. Alright, then it's 10 and this is 5 and you are asked to find this length here. So what we do is we make sure that we draw separately the small and the large one, and so we can label the fact that the small one has a dimension of 5, the large one has a dimension of 15. That's the mistake, isn't it, when someone says 10? Because the 10...
Yeah, 10's into the line.
45.
Base.
Right, so I know that 5 matches with this side. So what's the multiply by? 3. Therefore, this one, y, has to be the same thing. So it's 5. Nice and easy. Really easy question, that one. The hardest bit was identifying the fact there's two separate triangles. Okay?
Wait, what? Okay.
Because what people do is they label this side as 10 because of that 10, and then they would say it's multiplied by 2, and then they would say, well, that must be then 7.5. So all of that is, that's where the mistake gets made.
The 5 comes from the smaller triangle, right?
Yes.
Actually, never mind.
Right, you can always review that and finish off notes if you haven't managed to draw them all. It's on the video. I'll put it on straight away. Next question. You've got one on this.
Yes. Wouldn't if one side's 15, the other side's 15, would it be equilateral with the other side being 15?
Not necessarily, but it is isosceles, isn't it? But I'm not asked to find the third side. I'm not told any angles or anything. Jonathan.
Yeah.
Can you run through really quickly how you got y?
So, y is this length here, yeah? Yeah? Which is the bottom of that triangle. Now that bottom matches with this side here, which is this one. Yeah? So by using these sides here, I know that 5 for this one is times something to give me 15, which is the whole length, yeah? 10 plus the 5, so that's the 10 plus the 5. So what is 5 times what makes 15?
3.
Times 3. So now I know every single side must be times by 3. So I know that this side here matches with that y. Okay, so it's 15. Y multiplied by 3 has to equal 15. So what must it be? Must be 5. Okay?
So I have a
Different one. Well, Tally's next. Yeah, no, we'll come back. Any more questions on this particular one? No? Okay. Tally, what was the next question we got?
Okay, so it's in the unit review thing, and
Page?
page 41.
Page 41, question. Which question?
H.
Question H. 1, 2, 3. Question 5. H. Okay. Can you all turn to that then? Make sure we're all looking at the same thing.
Okay, that's fine.
What is?
Page 41, question 5H. This is a good one, actually. So we've got 15 x to the power of 4c multiplied by, guys, stop having your own little discussions. You don't need to talk your way through opening up a page. Okay, this is a very important one. You must know how to do this. Hint, hint. Okay?
Let's get this.
So, what does it mean when you've got two sets of brackets and nothing in between?
Multiplication.
Multiplication. Is there any addition or subtraction in there?
No.
So actually, I could happily just write this as 15 times, or multiplied by x to the power of 4c, multiplied by 7, multiplied by x to the power of negative 6c. Okay, so it's all multiplication. All right, I can only do that because there's no addition or subtraction. All right? So then I'm going to put things together. So I'm going to put the 15 multiplied by the 7, and then I've got the x to the power of 4c multiplied by x to the power of negative 6c. You don't have to do this, but I'm just showing you. Yeah?
Does the x negative 6c mean division?
We'll get to that point. Yeah, you're remembering that. But what's 15 times 7? Good comment. Got calculator.
105. Yeah.
405.
100.
Going to say 105 multiplied by. Right. So we've got. What are these called, by the way?
Exponents.
They are exponents. So we are using the laws of exponents. And what is the law that says when you multiply things? The x is called the what in this case? The begins with B. The base, yeah? X is the base. So when you've got the same base, what do you do with the exponents? Squaring's a specific one. Pardon? Not divide.
Add them.
You add them, yes. The law of exponent which we're going to use is if we've got a to the power of m and we multiply it by a to the power of n, we have a to the power of m plus n. We add them together. All right? The other one that you're thinking of is if we have a to the power of m to the power of n, then we have a to the power of mn. If we've got a to the power of m divide by a to the power of n, it's a to the power of m minus n. So we're just going to use that to start with. So what do we have? We've got x to the power of 4c plus negative 6c. So what is 4c's add negative 6c's? Forget the division bit
Wait, what is it? 4c?
at the moment.
4c minus 6.
Now it's just 4 add negative 6.
4, negative 2.
Negative 2. So this will be x to the power of negative 2c. Alright, now that is stage 1 of the answer. That is not too bad at this stage. Alright? In fact, a lot of times that will be considered perfectly good as your final answer. But if they say to you, you're not allowed, you must use positive exponents only. This then, the negative you've seen before, becomes division. So it ends up as 105 divided by x to the power of 2c. The negative gets dropped and it's converted to a division. Okay? So 105x to the power of negative 2c and 105 divided by, they're the same thing. All right?
Sweet.
Do you remember I said the other day that a negative in the power makes it a divide and then it becomes the denominator. All right?
Could I just... Yeah, actually, that's fine.
What's up?
Sorry, is that 100? Never mind.
Here?
Yeah.
Yeah. I'm hoping you don't need to just copy. I hope you're kind of listening and following through. Yeah, it is a 2C. Make sure you're not just writing stuff down, you are listening to what I'm saying. Okay? Right, does that answer your question? Yeah. Sasha, you had a question for us?
Okay, yeah. It's page 51, question 5A.
Page 51, question 5A. Can you all turn to it?
Actually, B.
B, okay. Question 5B. Okay, so we've got a ratio and we've got 8 to 11 is the same thing as 17 to m. Now, this is actually, hopefully you saw, they're pretty much the same thing as doing the similar shapes.
Yeah, I know.
Because when we did the similar shapes, we set up a ratio. So we've got the same idea. So we've got to figure out 8 times what gives me 17. So then 11 times that gives me what m will be. Okay? So, any ideas? Okay, so we can write it out again, can't we? We've got 8 times k equals 17. So k is 17 divided by 8, which we could turn to a decimal if you like. 2.125. Therefore, 11 times 2.125 must equal m. So what's 11 times 2.125?
22.
23.37.
Let's say times x or time.
Okay, this is why I say it when I'm writing it. There's just another thing about just writing rather than listening.
Why is it K?
Really what you need to do is write down after I finish talking. It's a K, isn't it? I used the same notation in the previous question. And you know what my X's look like? My X's look like that. They don't look like K's at all.
They look like C's.
They are, and I do that for a reason. Okay?
Doesn't look like the times.
Exactly. Right. Answer your question?
Yeah.
Sorted? Okay. Can you see, by the way, everyone, on that page 51, question 5, can you see how A, B, and C are just different ways, different parts of solving the same thing?
Yeah.
Okay. Right, next question. Owen.
So mine's not a specific, it's just like a general. So when you have to graph something with multiple lines, how do you label that?
You write the equation at the end of the line.
But like, how would you tell which line is like?
So if I draw this line, and that is y equals 2x plus 3, and I draw another line, which is y equals, I don't know, minus x plus 8,
But how would the person know which one is which?
because I've just written them at the end of the lines.
No.
The other option is to know that this one I would be able to tell crosses at 8, and this one crosses at 3, so...
What's an example? If the two are options.
You can leave the room if you want, Maisha, that's just rude. Do it again, you will be gone, and you'll get none of my help in my own time at all.
So, let's say one of them, like, it's handling two options for water into a tank. How would you label that? Does that make sense?
Write the equation at the end of the line.
I get that, but usually like if you have two options, you don't know what the options are by y equals 2x plus 3. Like, that's the example you have up there.
Yes, but that is for that line only.
But how would you know what that line is representing, I should say?
Because you just told me it's water in a tank.
But how would a person visualizing that with only the y-axis and x-axis labeled know what that one is? Wouldn't you like label it with what that means, that line?
Like say it's labeled, but I wouldn't. If this was water in a tank, I wouldn't be labeling it X and Y, I guess is what you're saying. This would be water height in the tank, and this would be time in seconds, so my equation would be h equals 2t plus 3.
Right.
But I have to label the axes as well. H is height and t is for time. The whole thing needs to be labelled.
I get that. So wouldn't the lines have to be labeled with what they
So
represent?
that's what I've done.
With what? With
The equation is written by the end of the line.
But what do you know let's say the option is
Guys, you're being rude. What if we all did that when it's your turn to ask help? What if you come to me at lunchtime and ask for some help, like some of you might want to do, and I just sit there and whistle and grin and hum?
I have an example in my book for like payments with different methods of payments.
Yeah.
And with all those lines, the person can't tell what line means what the line. We're wording this very poorly.
Maybe, because I'm just, do you know the equations?
Yes.
Then I just
know.
write them at the end of the line.
But let's say it's handling different options for money, then wouldn't you put...
But if they mean completely different things, they're not going to be on the same axes.
Yeah. Wait,
Yeah.
if all the lines were plotted on the same graph, first from payment methods, and it was like, how do you tell which one's which? Couldn't you just write, this one's PayPal, and this one's Visa?
That's what I'm saying, yeah. Like, how would you write, like, would you just put it at the top or put it on the side or something like that?
So you mean a key
Yeah.
for
On the line.
Yeah.
Oh, just-
you could do like the PayPal.
it? Line A, line B,
Yeah, you could do the PayPal line.
A equals
and then you could
PayPal.
do the Visa line. Or you could like color.
Yeah, colour, lots of options.
Alright, I was just wondering if there was one specific
No.
option that you had to follow.
As long as it's labelled so I understand. Okay, Michael.
I figured it out. On page 61, question 2A. How do you how do you find if it's a right, like once you get the do the equation and stuff, how do you find if it's a right angle?
Oh, okay, good question. Can we determine if this is a right angle or not? Right angle triangle. And how would I do it if I knew it was a right angle triangle and I was trying to find a side? Pythagoras theorem. So basically what we're saying is, I don't know what that's funny, but we're saying that Pythagoras' theorem works if it is a right angle triangle, yeah? So what we do is we try Pythagoras' theorem. So Pythagoras' theorem is a squared plus b squared has to equal c squared.
Instead of putting it the side.
So now we have all the sides. So I know that c is
13.
13. The other two, 5 plus 12. So I just need to check that that is true. So I've got 25 plus 144. Well, what does that equal? 169. And what is 13 squared? 169. So they match. So I'm happy. So therefore I know it is a Pythagoras theorem. If I had a different one, for instance, where I say, well, I've got 11, 5 and 7, and I would say, right, 7 squared plus 5 squared, does that equal 11 squared? Well, we've got 49 plus 25 should equal 121, if I'm right. But 49 plus 25 is actually 74, and 74 does not equal 121. Therefore, it's not a right angle triangle. The question then is this angle, we've already determined it's not a right angle, is it acute or obtuse?
Well, it's acute because it's less than.
Okay, because it's less than, we know that. Yeah, we know it must be an acute angle.
Are we speaking like as if you did have a protractor?
Yes,
Yeah.
definitely. Because it will say not to scale. Okay, and also if it says here, for instance, use Pythagoras' theorem to determine. If you then just went and measured it, you're not using Pythagoras' theorem. What I would say in general for you now, unless it says, so Dumb and Dumber, it's like we both go for a pen and knock their heads together, and still no sense. In general, in exams and things, unless the question says measure this angle, accurately draw this shape using a compass and protractors and that kind of thing, you will never be measuring angles, right? You should be if it says calculate, you're not measuring. Yeah? Next question. Nick.
Page 333.
Yeah.
Question for practice 4, question 1 and 2.
It's on the board. Practice 4, question 1. So this is good. So it says, solve the following linear systems using substitution. Verify each answer. So we've got 4x plus y equals 1. And we've got another one that is 2x plus 3y equals negative 7. Now the one thing we need to be aware of is that both of those equations give you what, if you were to draw them?
They both give you an axis.
Oh, X and Y?
If I draw the graph, it looks like a...
Graph.
No, if I just draw one of them.
It's like a diagonal line.
It'll be a straight line, is all I'm asking for, yeah? Blimey. Right? If I draw them both, I will have two straight lines, and they will... Daniel.
Sorry.
If I draw them both, unless they are what, they will cross. Parallel. Okay? So they're looking at crossing. So it says, solve them. So we're looking for the point where they cross, and that's where, if they cross, they share the same coordinate, which means the x and the y value must be the same, yeah? Yeah? So I'm looking for the x and y values that go into both of them, exactly the same x and y, and it works in both lines. Right? So for instance, if I said x equals 1, what would the y answer be for here? So 4 times 1 is
No, I know.
4. Plus what makes negative 1?
0.
No.
What?
Please don't laugh unless you've got the correct answer.
4 times.
Negative 3.
Guys, this is stuff we've done. If I want to know the y coordinate when I ask for an x one, it's like when we were plotting the points. If x is 1, we would do 4 times 1 plus y equals 1. So 4 minus
Negative
3. So y is negative 3. Okay. Now the check is, does it work in this one? So we've got 2 times 1 plus 3 times negative 3 should equal negative 7 if we're correct. Okay? So that's 2 minus 9 equals negative 7. Are we happy?
Yeah.
Okay. Now, I now know then, for instance, that the solution to these is x equals 1 and y equals negative 3. However, I did that off the top of my head. I had a guess and it worked. I got lucky. That's not what they're suggesting you do. Okay? What's interesting is we haven't done this and there's still people that are not writing any of this down and you know it's in your test. That's all right. But some people are scribbling on post-it notes and things. Okay? Slouching, but, all right? That's a guess method, which some of you like guessing, okay? But we need to use a different method, okay? But do you understand how the x equals 1 and y equals negative 3? What that means is that these lines will cross, and where they cross, the coordinate would be 1, negative 3, yeah? So it says though, it says do it by substitution. Yes?
So because we want to figure out, can we figure out what y is first?
Using what?
We can substitution. So you minus 4x from 4x.
Oh, okay, right, hang on. You're going the right way and I want to write it down. So I've got 4x plus y equals 1, wasn't it? And I've got 2x plus 3y equals 7, minus 7. Yeah, go on. Tell me what you were going to do.
So you minus 4x from 4x to get rid of it.
So we subtract 4x and do what?
And then with the 1, you minus 4x.
Yeah. So I've got y equals
Negative
1 minus 4x. Or minus 4, yeah.
And then we would have to add 1.
No, right. You have done the very correct first step. Okay, first step. I've got it as this one, you pick the right one as well. So I've got y equals. So the substitution means that if I've got y equals 1 minus 4x, you're happy how we got that? You should be. We've done that rearrangement. I can replace any y's with 1 minus 4x, yeah? Where's another y in this question? Over here, look. So I'm going to substitute the thing that I've just worked out for this. I'm going to replace it. So this here is going to go in instead of that y. So I'm going to rewrite this one as 2x plus 3 times 1 minus 4x equals negative 7. Okay? Now, actually, this is interesting because we're at a stage where you should now know exactly what to do. Because we're trying to find what now using this. I want to know what x is. So we're now solving this algebraic equation for x. And you all know how to do it. Yes, we've got to isolate x. Okay, so we're going to expand the brackets first, yeah? So we've got 2x plus 3 minus 12x, good, equals negative 7. Now what do we do? Good, collect it together. So 2x subtract 12x is negative 10x plus 3 equals negative 7. Minus 3, okay, let's subtract the 3 and we get negative 10x equals negative 10. Now we divide by negative 10 and I get x equals 1, which is what I had up there, yeah? We happy with that? So I guessed x equals 1 and now I've shown how I got it through substitution. Make sense? How would I find y? Don't actually need to do all of that now. Look here, look. What does this mean? So it means if I want to know what y is, I need to do 1 minus 4 lots of whatever x is, yeah? So if I replace my x with 1, so I'm substituting again, but I'm putting the... Okay, so I'm going to replace the x equals 1, and I'm going to put it in there, yeah? So I've got y equals 1 minus 4 times 1. So that's y equals 1 minus 4. So that's y equals negative 3. So my solutions are x equals 1, y equals negative 3. And is that exactly the same answer I got before?
Yes.
So I'm happy. So I've done it through substitution. Okay, should I pause that and let you write it down? So let's just go through this quickly then. We've got a cone, and we are being asked to find the volume of a cone, and we've got these dimensions, which are 8 and 6. What's the formula for the volume of a cone? 1/3 pi. Okay, so if you remember back to what we did before, the volume of any pyramid is 1/3 of the base. The base being the circle, which is the pi r squared, multiplied by the height, okay? The height being 8 in this case, so we've got volume is 1/3 multiplied by pi, multiplied by 6 squared, multiplied by 8. And that's it. We use our formula. And yes, if you don't use your formula booklet, you might struggle to remember that and get the answer wrong. But you have a formula booklet and you have the formula in there, so there shouldn't be any excuse, really.
So don't bring these ones today.
Don't bring your own. You'll get a fresh copy. We've printed them all out today. Okay? All right.